Let's continue talking about fundamental functions or formula in educational research. Now I'm going to talk about standard deviation versus analysis of variances. So when we say standard deviation, this talks about the degree of dispersion or the scatter of the data positive relatives to its mean. Standard deviation is actually one of the ways on how to find out the different measures in central tendency. So as you can see on the illustration, standard deviation is close to the mean as compared to analysis of variances. This is a statistical formula used to compare variances across the means or average of different groups. So you can see on the illustration that analysis of variances have different ways on how to interpret the data acquired on a certain test. Okay, so let's move on. Let's talk about standard deviation. What is a standard deviation? So, as like what I've said, it is a degree of dispersion or the scatter of the data points relative to its mean in descriptive statistics. It tells how the values are spread across the data sample, and it is a measure of the variation of the data points from the mean. The standard deviation of a data set, sample, statistical population, random variable, or probability distribution is the square root of its variance. Okay, so standard deviation has actually, it does have its own formula. So when we have a number of observation and the number of observation, that's x1, x2, x3, and so on and so forth, and then the mean deviation of the value from the mean is determined as summation of n is equal to xi minus x, or the mean, and that's the square root. However, the sum of squares of deviations from the mean doesn't mean to be a proper measure of dispersion of. If the average of the square differences from the mean is small, it indicates that the observations xi are close to the mean. This is a lower degree of dispersion. If the sum is large, it indicates that there is a higher degree of dispersion of the observations from the mean. Thus, we can conclude that the summation times xi minus x, or minus the mean, and that's the square root, is a reasonable indicator of the degree of dispersion or scatter. Now, let's take a look at the formula. So there's a formula for population and also a formula for the sample. So in order for us to get the population, we must determine what does it mean by those symbols provided. So x means the value in the data distribution, the letter u means the population mean, and the big letter N means the total number of observations. So as you can see, you need to get the square root of the population. Next, let's go to sample. Um, it's still the same. You must determine what does it mean by those symbols. So X, or the big letter X, means the value in the data distribution. Small letter X, X with a bar, that means the sample mean. And N, small letter N, is the total number of observations. How to find the standard deviation of grouped and ungrouped data. So group data, you're going to follow the steps and how you're going to find the result using the formula. First one, make the frequency distribution table with 6 columns. Write class and frequency in the first and second columns respectively. Second, find the total number of population is equal to summation of n divided by fi, or the frequency. Step 3, find the midpoint of each class. This is denoted by xi. It is the average of the upper class limit and the lower class limit. Then write xi in the third column. Fourth, find the frequency times the x. So it means product of frequency and midpoint. Write those values in the fourth column. Then step 5, find the mean using the number of using the formula 1 divided by n, or the total number of population, times the summation of n times frequency and the number of samples. Now, step 6, find xi minus the mean, or the sample minus the mean, and that's square root, and enter in the fifth column. Step 7, find xi minus x, or find the sample minus the mean, then the square root times the frequency, and enter in the sixth column. And step 8, find the summation of fi times xi, or the sample minus the mean, and that's the square root. Step 9, find standard deviation using the formula 1 divided by n and the square root of the summation of fi times xi, or sample minus the mean, and that's the square to the second power. Okay, next, here is an example for us to understand further how does the standard deviation works in a certain problem. So example is the mean and the standard deviation of marks of 200 candidates were found to be 40 and 15 respectively. Then it was discovered that the score of 40 was wrongly read as 50. The correct mean and SD respectively are 14.98, 39.95, B 39.95, 1498, C 39.95, 224.5, and none of this. So those are the choices on how you're going to get the result from the problem. So the solution is provided. So given the number of candidates, that's a total number of population, that's 200, with a mean of 40 and with a standard deviation of 15. Now, um, we're going to follow the steps provided to find out the standard deviation of a certain problem. So as you can see, the correct answer for this, let's solve the standard deviation of ungrouped data. The calculations for standard deviation after the different data distribution measures the deviation of data from its mean or average position. There are three methods to find the standard deviation. First one is through actual method. Second one is through assumed mean method. And lastly, step deviation method. So ungrouped data is not the same as group data. There's a certain range with the group data as compared to ungrouped data. It's just it doesn't have any certain range. So let's talk about standard deviation by the actual method. So this is how the actual mean method works to find out the standard deviation. In this method, we first compute the mean of the data values and then compute the deviations of each data value from the mean. Then we use the following standard deviation formula by actual mean method. So this is the formula. It's a standard deviation, the square root of all the summation of samples minus the mean. Um, that's on the second power divided by n, where n is equal to total number of observations. Consider the data of observation 3, 2, 5, and 6. Here, the mean of these data points is 3 plus 2 plus 5 plus 6 divided by 4. We'll come up with a result of 16 divided by 4. That's equal to 4. Now, let's talk about the ungrouped data using the step deviation method. The standard deviation method of group data also can be calculated by step deviation method. In this method, also some arbitrary data value is chosen as the assumed mean A. Then we calculate the deviation of all data values by using D is equal to X minus A. Then we calculate the deviations of all data values by using D is equal to X minus A. The next step is to calculate the step of deviation D using is equal to D divided by I, where I is a common factor of all D values. Choose any common factor in case of multiple factors. Now the standard deviations of ungrouped data by deviation method is found by the formula summation of all d to the second power divided by n minus summation of d divided by n in second power, where n is the total number of data values. Standard deviation of by assumed mean method. When the x values are large, an arbitrary value a is chosen as the mean, as the computation of mean is difficult in this case. The deviation from the assumed mean is calculated as d is equal to x minus a. Then the standard deviation from the formula by the assumed mean it's the same formula that we used from the step deviation method. Okay, now an example using the group data standard deviation. So I will play a video, so you can also follow the link to further understand how the standard deviation works in a group data. I'll play the video. All you have to do is to listen and follow the step. You can also take note on some important things as you watch the video.
In this video, we're going to talk about how to calculate the standard deviation of group data. So here we have a class of students, and in a table on the left side, we have different classes of grades. 50 to 59, we'll say that's an F. 60 to 69 is a D. This is a C, and so forth. And to the right of that, we have a column that tells us the frequency of those values. So this means that 5 students had a score between 60 and 69, and 12 students had a score between 80 and 89. So with this information, where we're given the class ranges and the frequencies, how can we calculate the standard deviation of the scores that the students had, let's say, on an exam? How can we calculate the standard deviation given this information? The first thing we need to do is determine the midpoint of the class ranges. So what is the midpoint between 50 and 59? The lower boundary and the upper boundary of that first range. To find the midpoint, we basically need to average the two numbers. So we need to add them up and divide by 2. 109 divided by 2 is going to be 54.5. Now, if we average 60 and 69 for the second range, that's going to give us 64.5. And if we follow the pattern, we can see that the next one is going to be 74.5 and then 84.5. By the way, one thing I want to mention is that for this particular problem, the student scores that they received on an exam, we're going to say that all of those scores have been rounded to a whole number, because 69.5 is neither in this range or in that range. So we're going to say that all of the scores are whole number values or integer values. Now, we need to determine the midpoint between those two. It's not going to be 94.5. So we're going to add the lower boundary, which is 90, and the upper boundary, which is 100, divided by 2. So this is 190 divided by 2, and that turns out to be 95. So that's the first step. You want to calculate the midpoint of all of the ranges that you see here. Now the next thing we need to do is multiply the frequency column by the midpoint column. So this is
Okay, I will stop the video. I'm going to, you can continue by following the link posted on this presentation. Now let's move on to the next slide. Let's talk about analysis of variance. Analysis of variance is another way on how to analysis of variance. Is a statistical measure expressed as a number that describes the size and direction of the relationship between two or more variables. So, analysis of variance will help you come up with a result that help you interpret a certain problem. Okay, so here's a formula of the analysis of variance. What does the analysis of variance reveal? The ANOVA test is the initial step in analyzing factors that affect a given data set. Once the test is finished, an analyst performs additional testing on the methodical factors that measurably contribute to the dataset's inconsistency. The analyst utilizes the ANOVA test results in an F-test to generate additional data that aligns with the proposed regression method. The ANOVA test allows the comparison of more than two groups at the same time to determine whether a relationship exists between them. The result of ANOVA formula, the F statistics, also called the F ratio, allows the analysis of multiple groups of data to determine the variability between samples and within samples. So, ANOVA test will help you find differences between two variables. That's one variable to another um, one variable. So here's the formula for ANOVA. F is equal to MST divided to MSE, where F is equal to the ANOVA coefficient. MST means mean sum of squares due to treatment. MSE means mean sum of squares due to error. ANOVA variance. So this is how the table looks like whenever you're going to conduct this test. Also, ANOVA has different types. We have one-way ANOVA and two-way ANOVA. So this means that there is a variation when it comes to the variables used in testing. Okay, how to perform one-way ANOVA. So I will play the video. You can follow the link as well. But I'm just going to show you a glimpse on how to do the one-way ANOVA. So I'll give you 2 minutes to watch this video.
Hi everybody, this is Eugene O'Loughlin, Lecturer in Computing at the National College of Ireland, and welcome to my series of short how-to videos. In this video, we're going to learn how to perform a one-way ANOVA test, and we're going to learn how to do it by hand. So first, let's examine the data that we're going to use in the example here. I have three groups of data, and these are the results of stress tests made on three different groups of workers. A shift that works from 4 p.m. to midnight, from midnight to 8 a.m., and the third group is from 8 a.m. to 4 p.m. And we've measured their stress levels and recorded the scores here. So we've got three groups, and an appropriate test to use to see if there's a difference between these three groups is an ANOVA test. The method I'm going to use here is based on the following formulas. We need to calculate our F statistic, and our F statistic is made up of, that's our test statistic, it's made up of the mean sum of squares between the groups, so we've got three groups in our example here, divided by the mean sum of squares within the groups. So in an ANOVA, of course, we have to take into account the variance between and within the groups. The formula for calculating the MSSW is up here at the top, and this tells us that we need to add up, so it's the sum of all the small values, G, all the values within the groups, for each number of groups, that's capital G. We need to calculate each value minus the mean of each group and square that We then divide by n minus k. N is the total number of variables, and k is the total number of groups. The mean sum of squares between is again the sum for all values, so these are the individual values g for the number of for all groups, capital G. We're going to multiply the number in each group by the.
Okay, let me start the video. Uh, as you can see, he's going to perform already the calculation to find out results with the use of those formulas that I was able to mention. Okay, now let's move on to
In this tutorial, I'm going to teach
two-way
you how to calculate a two-way
anova.
ANOVA
This is
by
another
hand,
type
manually,
of
and I'll walk you through it step by step.
test.
This
And
tutorial is
as you
part of
can
a
see, there's a
playlist
link
on two-way
attached
ANOVA,
on this video.
and in that playlist, I discuss how to
So I'll
calculate
play
two-way
the
ANOVA,
video
how to
for around
interpret the
2 minutes
results,
until
and how
we
to
reach the
calculate it using
point where you can
SPSS
see the
and Microsoft Excel.
formula, and then from
And you
there
can
you can
find a link to
also
the
use
playlist
this
right
link,
below.
or yeah, it's like a tutorial link on how you're going to
In this
perform the
tutorial, I'm going to teach you
two-way
how to calculate sum of
ANOVA.
squares for all the variables, and in a subsequent tutorial, I'll teach you how to interpret the results. So I've given an arithmetic test to boys and girls of different ages. Boys and girls of 10-year-olds, boys and girls 11-year-olds, and boys and girls that are 12-year-old. And in the middle is their scores. And I want to determine whether gender or age group, or both gender and age group, impact the test scores. So I have two factors, gender and age, I'm going to look at. I'm going to take my data and I'm going to create 3 different tables. And this is going to help me work with the data and manipulate the data quite a bit easier. So let me just organize the data. So the first thing I'm going to do is organize it by boys and girls. And I'm going to take the boys' data and I'm going to create its own table with that. So I have boys, 10-year-olds, and their test scores. And that's just that 4, 6, and 8 from there. Now I have the test scores for the 11-year-old boys. And finally, I have the test scores for the 12-year-old boys. Now I need a little space. Let me move that over right there. And now I'm going to do the exact same thing except for the girls. Like the boys, I'm going to have 3 columns of data, 10-year-olds, 11-year-olds, and 12-year-olds. And then I'll put their test scores in for each appropriate age group. So now I'm going to build a third table. And in the third table, I'm going to have 3 columns of data by age group and 2 rows of data by gender, boys and girls. The boys and girls is the first factor, and I'm calling that gender. The second factor I'm calling age group. So I'm going to have 2 rows of data with 3 columns in my table. So now I'm going to calculate the means, and the mean for the 10-year-old boys is 6. I'm going to put it in that first spot in the table, boys, 10-year-old. The mean test score for 11-year-old boys is 7. The mean test score for 12-year-old boys is 10. Now I take the average of all the boys, and the average for all boys, average test score for all boys is 7.7. Now I do the same thing for the girls. I take the average test score for 10-year-olds, which is 7. Then I take the average test score for 11-year-old girls, which is 10. The average test score for 12-year-old girls, which is 14. So the average for all the girls turns out to be 10.3. The average test score for all the 10-year-olds, boys and girls both, is 6.5. The average test score for all the 11-year-olds is 8.5. And the average test score for all the 12-year-olds is 12. And the average test score for all the children turns out to be 9. These averages are also called marginal mean, but I'm using the term average. So I calculated the mean value for test scores by different groups, by the 10-year-old boys, 11-year-old boys, 12-year-old boys.
Okay, let me stop the video. You can continue watching the tutorial on how to perform two-way ANOVA. So that's it for today, and have a great one.